For heavier stars, say 7 to 10 times more massive than our sun, the death comes in the form of a supernova. Here we have a cartoon of a neutron star collapsing. It collapses to a very small object, a star with iron core in free fall, and then it expands, and expanding shock is created, and tremendous amount of energy is released in it, almost 10 to the power of 53 ergs in a second. So these are very massive explosions, and they can outshine the whole galaxy. Here is an image of supernova 1998, and you can see that from this star, you are getting luminosity which is equivalent to all the luminosity of all the stars, 100 billion stars in the whole galaxy. Here we have an HR diagram again, which will tell you how uh, these more massive stars are sitting on the upper end of the main sequence branch, and as the mass decreases, the low mass sit here. Intermediate mass stars are sitting in yellow, and what we notice is in millions of years, the massive stars start evolving off. They start marching towards a red giant stage in millions of years, 10 million years. And in billion years or so, then the intermediate mass stars, they start marching towards the red giant, while the low mass stars, they take giga years, yeah, 10 giga years or more than that to march away. Okay. It's very interesting to notice that uh, that more massive stars evolve faster. Here we have stellar masses, 40 solar masses, 15 solar masses, 3 all the way to 0.5 solar masses. And this is the main sequence life of these stars. So 40 solar masses live for a million years, 10 to the power of 6 years, while 15 solar mass stars live for 12 million years. And 3 mass stars live for 400 million years. And 1.5 solar masses live for 3 billion years. And 0.5 live for 200 billion years, right? So as the mass is increasing, you notice that the main sequence life is decreasing. So this is very strange. Initially, it looks very strange that a star, if a more massive star has more fuel in it, which is going to get converted, but it is living for a shorter time. The reason is the mechanism with which it converts hydrogen to helium and helium to other heavier elements and so on is at a very energetic, more faster process, while the low mass stars. It's something like if you have a scooty, you fill in 2 liters of petrol, it would go on for 100 kilometers. But if you put 2 liters of petrol in a racing car, a Ferrari or so, it would go a few meters and stop. So a Ferrari consumes the fuel much faster than a moped does. In the same way, these low mass stars, they convert their hydrogen to helium at a much slower rate, hence they live on for a longer time. While the more massive stars, they consume it in a few million years. In the cores of these stars, massive stars, they end up as neutron stars or pulsars. They throw out the outer envelopes and end up as a very compact object, which are called pulsars or neutron stars. These are stars whose masses can be a few times, 3 to 4 times mass of the sun, but they are squeezed into a into a volume with a radius of that of a city, 10 to 15 kilometers. So when your rotational axis of the star and its magnetic axis are not co-aligned, then as it spins on its axis, the magnetic axis sweeps out a beam. So charged particles, as they are falling in, they get channeled towards the poles and they start accelerating towards the poles from either side. And as they accelerate, as charged particles accelerate, they radiate. And these beams come out from both the poles. And if it happens to be such that the beam flashes across our visual angle, we see it as pulses. And these neutron stars spin at very high rate because you have a conservation of angular momentum. As the radius squeezes up, the star starts rotating rapidly. So there are certain stars which have millisecond pulsars. In a hundredth of a second or so, it sweeps out a beam. It gives pulses. And when the stars are more massive, say 20 to 30 solar mass stars, the collapse does not stop as neutron stars, but they continue to collapse indefinitely and end up as a black hole. Black holes are those objects which have collapsed tremendously, and the gravitation, it is tremendous amount of matter squeezed into a very small area of space, such that the escape velocity from its surface is greater than the speed of light. So even light doesn't escape it, and we can't see it, hence these are called black holes. Before I end this session, it is pertinent to speak about Chandrasekhar limit. There are various Chandrasekhar limits, but this is the limit which is most popularly spoken about. 1.44 MSun. This is the maximum mass a stable white dwarf star can have. So Chandrasekhar calculated what is the maximum limit a star can have, which can withstand, which can be held by the degeneracy pressure. And it is given by this, it is 1.44 solar masses. So, cartoon which shows the whole story in a nutshell. We have a stellar nebula which becomes a star. The star, depending on its mass, lives as a main sequence star for a certain time. And then it revolves into a red giant. It becomes a planetary nebula and ends up at a white dwarf. More massive stars, they become red giant and then super giants. They blow up as supernovae and end up as neutron stars or pulsars and black holes. Here is a periodic table which shows how elements are created in the universe. It's color coded. Blue indicates the ones which were created, the Big Bang fusion. So mostly hydrogen and helium were created at the early time Big Bang. And the ones which are coded with orange are the ones which are created by merging of neutron stars. The light yellow ones are the ones which are created by dying low mass stars. And the purple ones are the ones which are created by cosmic ray fusion. And green ones are the exploding massive stars. And these light blue ones are the exploding white dwarf stars. So everything which you get, all the elements in the nature, they are, some of them, hydrogen and helium were created at the Big Bang, but all other elements are created either as stellar stars evolve at the centers or when stars explode as or they collide and merge as neutron stars, low mass stars. So all the elements created in the universe are byproducts of star stellar evolutions. Thank you.